Hi everyone, welcome to Vedantu NEET English. I'm Diksha Ma'am, your chemistry master teacher. So students, today we are going to do lecture 3 of solution chapter, which is very important that we are going to discuss is colligative properties, right? So everybody do let me know in the chat box if I am clearly visible and audible to all of you or not, so that we can start with the lecture that is colligative properties. So guys, in colligative properties, right, what you have is 4 colligative properties: relative lowering, boiling point elevation, depression in freezing point, and osmotic pressure and osmosis, right? So we are going to cover all of that in today's lecture, right? Okay, everybody, are you all ready for that or not? Do let me know in the chat box, right? Yes, ma'am. I want to see your energy. Where is your energy, guys? Very good evening, Govind, RSN, Shah, Blessy. Yes, I want to see your energies in the chat box and do hit the like button here, right? Why there is no energy, right? Why the energy is so low? Not interested in colligative property, this state I am telling you that from this lecture you are going to definitely see 1 or 2 questions in your exam, right? This is that important chapter, this is that important topic, the most important topic from solution chapter, right? Okay, yes. So now let us start with the session, but before that let me see, I'm going to open the uh, live session that I took the lecture before this particular lecture, that is lecture number 2 of solution chapter. That was about ideal, non-ideal solutions. Let me see how many of you have actually done your homework, right? How many of you have done? We are ready to listen, ma'am. Perfect. I can see very good, Lakshmi. Please bring the next lecture of full colligative property of this chapter as soon as possible. Done, Lakshmi. It is here. Lakshmi has done her homework. Very good. Thank you for asking free classes for future. Thank you so much. Lafita, I would also want you to answer the homework, right, that I gave you, right? Coordination compound that I'll take, ma'am. Myself, Ria, answer you have given. Very good. Explanation is not, explanation is also given. That's great. Awesome. Right? That's awesome. Okay. Until complete the syllabus. Yes, that will be there. Right? Okay. Chal. Now let us start this. Let us start this session. Right? First thing is, guys, what were your last homework? This was the homework, the boiling point, where students, 6 students have given the answer, right? Now, the homework was the boiling point, and I want 15 plus students to do the homework if you want to get the DPPs of each lecture. If in any lecture I get like 15 plus students who are doing the homework, I'll definitely give you DPPs of each topic. But for that, you need to do that, right? Okay. So, boiling point or isotropic mixture of water is less than that of water. Ethanol, the mixture is no deviation, there is deviation. So, basically, they are saying that boiling point of a azeotropic mixture of water is less than that of water. Boiling point is less. That means it is minimum boiling azeotrope, right? When minimum boiling azeotrope is there, it is definitely deviated, right? No deviation, that is not possible. The solution is unsaturated. There is no link. Is this positive deviation or negative deviation? The simple thing is, whenever you have minimum boiling azeotrope, in that case, vapor pressure is increasing. And vapor pressure is increasing in which case? Positive deviation or the negative deviation. See, in positive deviation, what happens? Vapor pressure is greater. In negative deviation, vapor pressure is less than the expected. So you will say in the positive deviation, you have vapor pressure is increasing. So answer is going to be B is the correct answer for the first question. That will you solve questions today? We will definitely solve. Physical chemistry is 0. Can you see the 0? It is 0 without practice questions. I'm also going to take up NEET previous year questions. Don't worry about that, right? Because without questions, nothing you can do. If the intermolecular force between two benzene molecules is approximately the same as between two toluene molecules, which of the following is incorrect? See, it means it is an ideal solution. And in an ideal solution, delta H is 0, delta V is 0. Minimum boiling azeotrope they will not form. They will not form. Wait a minute. They will form a minimum boiling azeotrope. They will not form ideal solution. They will form ideal solution. This is incorrect. They will form a minimum. This is also incorrect. So C and D both are incorrect here. Okay. C and D both are incorrect here. Right? Is this chapter very important, ma'am? Yes. In every chapter, some topic is very important, and this is that topic which is very important from solution chapter. Right? Okay. So let's start with colligative properties. Let's start with colligative properties. Colligative properties. Right? What are these colligative properties? These are those properties which depend upon number of solute particles. Number of solute particles. Right? What is the number? What is the concentration of solute particles? These colligative properties are those which depend upon the number of solute particles. Right? So what do you mean by colligative? That means co means together, ligare means to bind. Right? So together, when solute particles bind together, how many particles bind together? That is called the colligative property. If it depends upon how many particles that are there. So property of solution which do not depend upon nature of the solute. It doesn't matter what is the nature. What it depends only on the number of the solute particles. If you talk about colligative properties directly proportional to number of solute particles, right? And we have 4 colligative properties. That is, first is relative lowering in vapor pressure. Second is elevation in boiling point. Then depression in freezing point. Then you have osmotic pressure. These are the 4 colligative properties that we are going to talk about. Right? Now, we are going to do one by one. First is relative lowering in vapor pressure. Right? For that, you need to understand one thing here, that whenever I am talking about relative lowering in the vapor pressure, right, I am talking about vapor pressure. I am talking about vapor pressure. And all the properties, there will be some solvent in which you are adding non-volatile solute. Always we are going to add non-volatile solute. Now, can you tell me what is the non-volatile solute? Always and always you are going to add non-volatile solute. Non-volatile solute is which does not form vapors by itself, like sugar, salt. They don't form vapors. So these are non-volatile solutes, right? Always we are going to add non-volatile solute. Now understand one thing. For example, you have a beaker, right? You had water in this. You have water molecules in this, right? Now you have added what? You have added non-volatile solute, let's say sugar into it, right? Now I am saying that the vapor pressure is going to decrease here. You will ask me, ma'am, why it will decrease? See, understand one thing, right? Earlier you had some water that is interacting with each other. Water molecules are interacting with each other, right? It's like you meet your favorite celebrity, right? And you are interacting with them, right? Then there is some non-volatile bodyguards, right? That will actually safeguard that celebrity. Now you won't be able to meet that person. Why? Because there is bodyguard, right? Which is the celebrity is surrounded by this bodyguard, right? So now what will happen? These non-volatile bodyguards, which will not volatile just like that, they will not be scared of you, right? So what will happen, right? The chance of you interacting, right, with the celebrity will be lower, right? That means you can't take out the celebrity just like that. You can't vaporize the celebrity just like that. You can't talk to them very easily when they are, surrounded by so many bodyguards. Same case, sugar particles are acting as bodyguards only. You had water molecules, they were interacting with each other, they were forming vapors, right? They were forming vapors here, 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 here. But what happened when you added sugar into it, which is non-volatile, right? What will happen? It will cause hindrance in the path of the vapors of water, right? Because of that hindrance, vapor pressure will decrease here, and that is called lowering in the vapor pressure, right? Is that clear, students? What is lowering in vapor pressure? If that is clear, then do let me know in the chat box, right? Can I leave this lecture or I'll create a problem for me, ma'am? This lecture solution chapter is actually not that dependent on your class 11th, right? You just need to know what is concentration terms. If you have seen the lecture of concentration terms, you can watch this. If you have not seen that lecture, then I would not advise you, right? Okay. Yes. Okay. Now, that is your lowering in vapor pressure. But here they are talking about the relative lowering. That means in comparison, you have to talk about. So, whenever I talk about relative lowering, see what is lowering? Initially, it is P naught minus P. Relative lowering is P naught. So, when you decrease, the vapor pressure is decreasing, right? Okay, that is of pure solvent. Something amount is we are taking out from here, and you get the lowering in vapor pressure. Relative lowering means in comparison. Now, this is directly proportional to the mole fraction of the solute, right? That is directly proportional to the mole fraction of solute, And solute we mentioned by 2, right? So, we can directly write 2 here. Now, students, what you know that what is mole fraction of solute? That is nothing but N2 by N1 plus N2, right? This is P naught minus P divided by P naught, right? Now, if you see this here, solute is very small as compared to solvent, right? So that's why N2 is very, very small as compared to N1 if the solution is highly diluted, right? So you can say that for highly diluted solution, for high dilution, right? For high dilution, N2 is very small. So we can say N1 plus N2 is approximately equal to N1 only because N2 is very small. So can I just directly write here P naught minus P divided by P is equals to N2 by N1, right? What is N2? Weight by given mass by molar mass. So can I write it as W2 by M2? This is W1. This is M1, right? And this will be your final formula that you will use in the numericals. Okay, this is going to be the final formula that you will use in the numericals for relative lowering in the vapor pressure, right? Okay, okay, cool. Now let's see, this also I have told you in case of very dilute solutions what will happen. Now let us see the question of NEET 2025, that is 5 mole of liquid X and 10 moles of liquid Y make a solution having vapor pressure 70 torr, right? Now, how many of you have watched my session of unit conversions, right? Because see guys, I am not going to tell you in every single video about the unit conversion. I will recap definitely, but every like detail of that unit I can't tell you in every single video. So I have made a specific video, right, for unit conversion. You can go and watch that. That will be very, very helpful for you, right? Okay. Yes. Now 5 moles of X. That means, can I say this is, let's say N1, 10 moles of liquid this, so let's say this is N2, makes a solution having vapor pressure of this. That means this is P. The vapor pressure of pure X and Y are this and this. So P naught of X is given to you, that is 1 is given to you. P naught of 2 is given to you. Which of the following is true regarding the above thing? Okay, right? Hmm. So they're asking you which of the following is true regarding this. 5 moles and 10 moles are given to you, right? Number of moles are provided to you, right? Total pressure, the deviation is given to you. Pure vapor pressure is given to you here and here. And they are asking you the solution is ideal, have volume greater than sum of individual, shows positive deviation, negative deviation. Let's see how we are going to solve this question, right? Firstly, see one thing, liquid, all the given information we have written here. This is 5 moles, that is of liquid X. You can also write it as NX. You can also write this as NY, right? Total moles in that solution is going to be, total moles is going to be 15, this plus this, right? Mole fraction, right, of the compound, if you let's talk about mole fraction of X. Mole fraction of X is going to be number of moles of X divided by total number of moles, that is 1 by 3, right? Okay, mole fraction of Y is going to be, this is mole fraction of Y, that is number of moles of Y divided by total number of moles, that is 10 by 15, that is 2 by 3. Now you have mole fraction of both of them, right? How you will write it? See, the vapor pressure of pure liquids are this and this. This is the vapor pressure of pure liquids. Now we have the mole fraction, we have the pure liquid, we have the P value, that is after mixing these two things, what will happen. Using Raoult's law for an ideal solution, the vapor pressure is calculated as this thing, right? This is the vapor pressure, right? This is your mole fraction, P naught is given, mole fraction, P naught is given, right? You put all these values. If you see, this is coming out to be 73, and in the question also it was given to be 70. That means the calculated that we expected is more, right? The one that we expected, right? That we no, the one that is in reality, that is coming out to be 70. The expectation was 73. That means the vapor pressure has decreased. So whenever the vapor pressure decreases, can we say it will leading to lower vapor pressure? So what has happened here is negative deviation it is showing, because in negative deviation the vapor pressure decreases. Okay, understood? Yes, everybody. Now, why this question, right? Because if you see this question to you, it might feel like, ma'am, they are asking about relative lowering in vapor pressure. But in reality, we were supposed to apply Raoult's law, right? So that's why these kind of questions are very important for you to do, right? Okay, now let us see the next one. The correct option for the value of vapor pressure of a solution at this benzene to octane in mole ratio is this. Okay. Now they are saying at 45, the correct option for value of vapor pressure of solution. That is what we want to calculate. Just give me a. Okay. Just give me a second. Okay, okay. Okay, Ruby, I'll check that. Okay. Now, let us see this. The correct option for the value of vapor pressure of the solution, we have to find out. With benzene to octane, molar ratio is this. Molar ratio of benzene and octane is given to be this. Okay. We can say mole fraction kind of thing is given to you. At 45 degrees Celsius, the vapor pressure of benzene is this and that of octane is this. Benzene is given to be this, octane is given to be this, vapor pressure of assume ideal solution it should be, right? And here it is P naught, this is vapor pressure of benzene, this is P naught, this is vapor pressure of octane, right? And the molar ratio is also given to you, right? they are asking you the correct option of vapor pressure. So again, tell me one thing, whether we are going to apply relative lowering in vapor pressure or Raoult's law. Let us see if you can identify that or not. Are you going to apply relative lowering in vapor pressure or Raoult's law? What you are going to apply here? See, simple thing is we will apply Raoult's law here, right? That is P is equals to P naught A mole fraction of A, P naught B mole fraction of B, right? Mole fraction, that is given to you. The ratio of benzene with octane is given to you. That means we can say that this is a mole fraction of benzene, because benzene to octane is given to you. You can approximately find that, right? That is 3/2. So in the terms of benzene only, you can calculate this with the help of Raoult's law. That is, we know that mole fraction ratio is given to be 3:2. So we can say that if you see, this is 3x, this is 2x, right? Because whenever ratio is given to you, you can take it as x, right? So let's say mole fraction of, this is number of moles of C6H6, let's say benzene is 3x, mole fraction of octane is, let's say, 2x. So total mole fraction will be 5x. So mole fraction of benzene is going to be 3/5x, 3x by 5x, that is 3/5. Of octane is 2x by 5x, that is 2/5. Once you have the mole fraction, this is already given to you by applying Raoult's law, because they have given that this is an ideal solution. So you can directly put the values and you will get your answer here. Right? Okay, students? Clear? Next question is, an aqueous solution of this molal in Ki, which can call the vapor pressure solution to increase. Right? Now here what they have given is, this is an aqueous solution in this much molal in Ki. That means molality is given to you. Which change will cause a vapor pressure of the solution to increase? Right? We want the vapor pressure of the solution to increase. Can you tell me how it will increase? If you want the vapor pressure to increase, that means there should be positive deviation. If I see there is positive deviation, in that case, what can happen here? In case of positive deviation, see, simple thing is, in case of positive deviation, what might have happened is, interactions will be less. We need to find out where the interactions will be less. By adding NaCl, by adding Na2SO4, or addition of 1 molal Ki only, addition of water. Where the interactions are less, that is going to be your correct answer. So addition of solute decreases the vapor pressure. Right? We know that addition of solute will decrease the vapor pressure, and that too we are talking about non-volatile solute. So here what you have is aqueous solution of this, which change will cause the vapor pressure of solution to increase. We want it to increase, right? As some sides of the surface are occupied by solute particles, resulting in decreased surface area and hence decrease. However, addition of solvent, when you add a solvent into it, dilution increases, right? In that case, the surface area of the liquid will also not decrease here, right? More vapors will be formed, that will be increased vapor pressure, right? So you can say addition of water to aqueous solution, because water is a solvent. All the other things are not your solvent. Water is a solvent. So addition of water, what it will cause? It will actually increase the vapor pressure, because water is a solvent. It is not a non-volatile solute, right? Water is a universal solvent. So answer is going to be D is your correct answer here. Right? Okay, students. Now, let us see the next part, that is elevation in boiling point. Right? Elevation in the boiling point. So if you talk about elevation in boiling point, see, simple thing you have to understand here. First, you have to understand what is exactly boiling point, right? Boiling point is how it is connected to the atmospheric pressure. Let's understand that first. If you talk about boiling point, let's say you have water, you are boiling it. So what will happen? Once it will reach its boiling point, it will start forming vapors, right? Okay, it's not like initially it was not forming vapors. Simple water, if you keep somewhere, that is also forming vapors, but in a very less quantity, right? But as you increase the temperature, vapor pressure will increase, right? And boiling point is when the vapor pressure of that liquid is equal to atmospheric pressure. Okay, so how we can understand that? Let's see that this is the atmospheric pressure, right? This is your atmospheric pressure. This is the vapor pressure of simple liquid that is there. Now, as you increase the temperature, boiling vapor pressure increases, and you touch a point where your vapor pressure is equivalent to the atmospheric pressure. At that temperature is called the boiling point. When the vapor pressure of that liquid becomes equal to atmospheric pressure, that temperature is called the boiling point, right? Okay. Now, temperature at which vapor pressure of a liquid becomes equal to external atmospheric pressure is called boiling point. And if you see here, when you have simple water, you are boiling it, things will be like vapor pressure is increasing, right? But when you add non-volatile solute into it, can you see vapor pressure decreases or increases? Decreases, that we have seen lowering in vapor pressure. So see one thing, this is atmospheric pressure, this is the vapor pressure of pure liquid, right? Now, to become equal to atmospheric pressure, this much temperature it needs, right? But if you add non-volatile solute, its vapor pressure decreases, and now this much temperature it needs. That means boiling point is increasing here. So we can say vapor pressure decreases, boiling point increases. That's why it is called, on adding non-volatile solute, there is elevation of the boiling point, right? Okay, students, if that is clear to everybody, then let me know in the chat box. Now, if you see delta TB, that is called the difference, how much temperature we have changed, right? That is delta TB is equals to KB, that is albedo constant. This is the constant here, which is called as albedo constant or molar elevation constant or molar elevation constant, right? Okay. And how, ma'am, this is, ma'am, why it is a colligative property? Because just like relative lowering in vapor pressure is directly proportional to mole fraction, this is directly proportional to molality, right? This is directly proportional to molality. You can say molality. Now tell me one thing. If you're writing the difference here, should you write it by TB minus TB naught, or should you write it by TB naught minus TB? What you should write here? TB minus TB naught or TB naught minus TB? Always remember, it is larger minus the smaller value. Larger minus the smaller value. If you see this here, larger value, there is increase in the boiling point. So this, when you add non-volatile solute, boiling point is larger. So that's why this is the true thing. This is not true. So we will always write TB minus TB naught. TB naught. Molality is nothing but it is number of moles of solute divided by weight of solvent in kilograms. So we can also write it as number of moles is nothing but W2 by M2. This is W1. If you write this is also in grams, then this will be multiplied by 1000. And this multiplied by KB is your formula for elevation in the boiling point, right? That is the formula for elevation in the boiling point. Very, very important formula, right? Can you see this, students, here? Can you see this? Yes, everybody, do like the video. Let's see how many likes you have done. I think it should cross 50, but I trust you that you will not make it. Let's just 10 more to 50. So let's cross it till 50, right? By the end of this topic, that is elevation in boiling point, let's make it 50. Okay, so that is your elevation and boiling point formula, right? Now, let's see the next one, that is graph. For graph, understand this, I know graph, some students find it very difficult. So simple thing is, I told you that let's say this is your atmospheric pressure. Let's say this is your atmospheric pressure, right? Now, let's say the vapor pressure of pure solvent is, I am representing it by this. Now, when your vapor pressure, when you add non-volatile solute, vapor pressure will decrease, right? This is vapor pressure of solution. Now, can you see this? Can you see this? TB naught is pure solvent till atmospheric pressure, the temperature difference, that is TB naught. TB is nothing but when vapor pressure of solvent reaches the atmospheric pressure, that is TB, right? Now, what is going to be the value of delta TB? The difference between TB minus TB naught, that is, this is called delta TB. Okay, same diagram I am going to draw in the form of graph, right? If you see the graph, this is temperature, this is vapor pressure. Now tell me one thing, temperature and vapor pressure are directly proportional, isn't it? As you increase when you heat some water, right? You put it on the heater or you on the stove, what happens? It starts boiling, right? Vapor pressure increases. So as temperature increases, vapor pressure increases. So that will be a like straight line here, almost a straight line, right? Okay, it will be like this. Now, if you see this here, this is the atmospheric pressure that is fixed. I have fixed it here, that is 1 atmosphere, that is fixed, right? Because in the case of vapor pressure, I have fixed it, that is your atmospheric pressure, right? Now, initially the vapor pressure of solvent was higher. So that was the vapor pressure of solvent, which definitely depending upon different temperature. As you increase the temperature, solvent vapor pressure also increases, right? Talking about the vapor pressure of the solution, that is lower than the solvent. So that's why I'll write the same thing here, that is lower than the solvent, right? Now the point where solvent and atmospheric pressure is equal, that is called TB naught. So I can express this as, I will rather write it as this. Wait a minute. I'll write it as this. So here you can express it and here also you can express it, right? So that will be expressed as, this is nothing but TB naught, this is nothing but TB, and the difference is delta TB. Okay, that is how you draw the graph of elevation in boiling point. If that is clear to everybody, then let me know in the chat box. Is that clear? Everyone in the chat box, is that clear? Right? Is that clear? Yes, students. Chal. Now let's do some questions, right? First is, at 100 degree Celsius, the vapor pressure of the solution is 6.5 of the vapor pressure of a solution of 6.5 solute in this much water is this much. The Kb is this, the boiling point of the solution is this. See, two things are given to you, right? One is they are asking you the boiling point of the solution. That means Tb is what they are asking, right? Vapor pressure of a solution of this in water. Tell me vapor pressure of, or you can say boiling point of solvent. Boiling point of solvent is expressed as TB naught. Here solvent is nothing but water, right? So what is the boiling point of water? 100 degrees Celsius. So can I write that I already know what is the value of TB naught. I just need to find the value of TB. For that, TB will be equals to, we know that delta TB is equals to TB minus TB naught. So can I say TB will be equals to delta TB plus TB naught, delta TB plus TB naught. So you just have to find the value of delta TB here. You add 100 into it, you will get the value of TB, right? So let's find this value first. That is delta TB, right? So let's see how to find the value of delta TB, students. Tell me. Delta TB is nothing but, it is given to be vapor pressure of a solution of this much solute in this. Okay. KB is given to you. Molality is nothing but molality. Okay. 6.5 gram of solute in 100 gram. We have no idea what is the solute, right? 6.5 gram of solute in 100 gram of water. That means, can I say that molality is number of moles, that is weight of solute. It is nothing but W2 by M2 multiplied by W1. This is 1000 multiplied by KB. If you see this here, they have given you the value of TB, KB. We have W2, we have W1. We can easily solve the value of delta TB if you know what is the value of M2. And to know the value of M2, they have given you this pressure. Vapor pressure of the solution is 732. That is the reason they have given you, from this particular case, you will find the M2 here. Firstly, tell me if that is clear what we are going to do here, right? Okay. N Avasti is a very good for physical chemistry questions practice. Okay. So this is your find M2 here, right? How you will find the value of M2? P naught minus P divided by P naught is equals to, right? N2 by N1, that is nothing but W2 by M2 multiplied by, this is W1 multiplied by, this is M1. If you see molar mass of water, we know that that is 18. W1 is given to be what? 100 grams, right? This M2, we know that value, we have no idea. This is what you will calculate. W2 is given to be 6.5, right? And this P value is also given to you, that is 732. Now tell me, at 100 degrees Celsius, what is the atmospheric pressure? Atmospheric pressure is nothing but 760, right? So you will just write the value here, that is 760, right? Once you, that value you should know. If you know this value, only then you will be able to solve this. First, you will solve the value of M2 from here. Then you will put the value of M2 here. You will calculate the value of delta TB. Then to this delta TB, you will add 100 and you will get the value of TB. That is the question of NEET 2016. That is your COVID pattern question. Okay, pre-COVID pattern question. Students, tell me if that is clear to everyone of you. Why we have always, I ask the students to go reverse, right? First, we know that for delta TB, I know I need to find TB naught. That I know, right? For delta TB, I need to find the value of M2. Everything else is given. M2 hint is given me. They have given me the value of this vapor pressure. I can apply the formula of relative lowering and boiling point, and this is a question of where two colligative properties application is there, and you are getting your answer here. So what we are getting here, right? We know that P naught, I told you that P naught you should know. This is what you should know, that atmospheric pressure is 760 mm of Hg or 760 torr, right? So here, applying this formula, you will get the value of M2 here, right? They have calculated the value of N2, but you can also calculate M2s, one and the same thing only, right? So after that, you put this value in delta TB. TB naught is 100, right? You solve this and you will get your answer here. Right, students, if that is clear, then let me know. I am not Antaryami, guys. I need to ask you, only then I'll get to know if that is clear or not. Right? Okay. By the time you're answering me, right, I'll wait for your answers, right? Let me see. When you will answer me, then only I'll join you here. If you're not interested in answering, ma'am is also not that interested that like a robot I'll teach you here, that I don't want. If you are like ready to answer things, then that's great. If you're not ready, then that's also good. Let me see how, like, the students who are interested. Okay, none of you wants to answer, huh? Chal. Okay, then great. I will not look at your charts, only as simple as that. That's only what I can do for the treatment that you give to a teacher. Excellent, guys. I'm so proud of you. So proud of you. Great. Awesome. Clap for you. Okay. Next question is the boiling point of 0.2 mole per kg solution of X in water, right? Solution of X in water is greater than the equimolar solution of Y. Which of the following statement is true? So this is your AI PMT 2015 question. The boiling point of 0.2 mole per kg, right? Can you see mole per kg? Can you tell me, is this molality? Is this molarity? Number of molarities, number of moles per kilogram of the solvent, right? That is your molality. So here they have given you the molality, right? So that is your molality. Boiling point of this solution of X in water, some X solution is there in water, is greater than equimolar solution of Y in water, right? Boiling point of this much of X in water is greater than equimolar. Equimolar solution of Y in water means where the molality will be, that means the moles are equal here, right? Equimolar solution is there, right? So here it is 0.2, there it will be 0.5, right? If molality and boiling point are directly proportional to each other, so now they are asking which of the following statement is true. Molecular mass of X is less than molecular mass of Y. Y undergoes dissociation in water, X has no change, X undergoes dissociation, molar mass of X is greater. That means we have to look for the molar mass here. Molecular mass, that is M2. So if you see this here, we have this particular formula, right? Now, wait a minute. In this case, so dissociation is there now, so we will not talk about this question here. Because I'll just show you this question, right? But we are not going to solve this question here, right? Because definitely, because in one of the question, one of the options, there is dissociation, and that will be there in case of Van Hoff factor, right? And Van Hoff factor we are not going to discuss today, that we are going to discuss in the next lecture. So that is, we will discuss in the next lecture, right? Okay, now let's talk about the next question here, that is 2 moles of each ethylene glycol and glucose. You have ethylene glycol and glucose are dissolved in 500 gram of water, right? The boiling point of resulting solution, they are asking you. Two things are given to you, 2 molar of each. This is also 2 mole, this is also 2 mole, right? 2 moles of each are given, and the mass of water is, that means W1 is given to be 500 grams, right? N2 is already given to you. So N2 divided by W1 multiplied by 1000. That will be the molality of each M1 and M2. So you can also write it as, you can also write one thing as here, number of moles is given, no? So what you can do is, molality of 1, this will be molality of 2. Molality of 1 is nothing but 2 divided by 500 multiplied by 1000. So this will be this 2, so that will be 4. Here will be 2 divided by 500 multiplied by 1000. Again it will be 4, right? So answer is going to be 4 plus 4. Total molality is M1 plus M2. That is going to be 4 plus 4, that is 8, right? Elliptoscopic constant, that is Kb, is given to you, right? Now if you see that, we know the formula that they have asked you the boiling point of resulting solution. So delta Tb you have to calculate, add 373 into it, then you will get your answer. Because see, what is the value of Tb naught? Tb naught is nothing but that is the boiling point of water. That is 100 degrees Celsius, that is 373 Kelvin, right? That is the value of Tb naught. So Tb will be equals to Tb naught plus molality multiplied by Kb, right? TB naught is 100, molality is 8, multiplied by Kb is 0.25, and that will be the answer for TB here. Okay, students, that will be the answer for TB. 100 plus 8 into 0.52. Solve it and you will get your answer. Here, you can differently solve it. 4 into this and this. I have solved it together. Answer will be same. You will get 4.16. That is your delta TB. So, what you will do here is 100 plus 4. Not 100. Sorry. You're writing this in Kelvin now, so it will be 373. 373 plus 4.16 will be your answer here, right? So answer is going to be 377.3 is your correct answer after solving this. A is the correct answer. Very good, excellent, right? Next question, next topic is depression in the freezing point, right? Next topic, students, we have is depression in the freezing point. Let's talk about this topic. Let's talk about this topic, everybody. Chal. Now, just the same way you have a formula, a definition of boiling point. The same way you have a definition of freezing point. Freezing point says that you have, okay, we are comparing it with vapor pressure of solid solvent. Okay, tell me one this, vapor pressure of liquid is more or vapor pressure of solid is more? Vapor pressure of liquid is more or vapor pressure of solid is more? If you talk about vapor pressure of liquid, that can easily vaporize as compared to solid. So liquid will have more vapor pressure. So if I draw it like this, that this is the vapor pressure of pure solid, right? This is the vapor pressure of liquid solvent, right? This is solid solvent, right? Now tell me one thing that is static in all the cases. Whenever we add non-volatile solute, vapor pressure will decrease. That means the vapor pressure of solution will be less as compared to liquid state. Now understand one thing. When we talk about solid solvent, we have to equate this with this. So this is the vapor pressure of solid solvent. This is the vapor pressure. Let's say this is the vapor pressure of liquid, right? So now liquid, when we freeze it, its vapor pressure become equals to the vapor pressure of solid solvent. That is called the freezing point. When you start decreasing the temperature and it becomes equal to the vapor pressure of the solid solvent, that is called the freezing point. Now this vapor pressure has decreased when you add non-volatile solute. So now this much is the freezing point, right? So earlier you will see the freezing point is when vapor pressure becomes equal to vapor pressure of liquid solvent. So that is your TF naught. That is freezing point of pure solvent, right? That is called TF naught. So you can write it as TF naught here, right? Okay, students. Now, okay. Now I'll just write it as this is your TF naught. And if you say this thing, when vapor pressure of solution becomes equal to solid solvent, that is called TF. Now, can you see which one is less? TF is less as compared to TF naught. That means there is depression in the freezing point. That's why we are saying freezing point is decreasing in this case, right? That's why we are saying freezing point is decreasing in this case, right? Okay, so lowering the vapor pressure of the solution causes lowering in freezing point as compared to pure solvent. And what is freezing point? When liquid state become equal to the same vapor pressure as solid state, right? Now, if you see that exists in dynamic equilibrium, this is that we have also studied in lower classes, that when you have when you see that actually the ice is not getting converted, not getting melted at the same temperature, in reality it is actually in the dynamic equilibrium. That means the rate of melting and freezing has become equal to each other, right? Now students, if you see the formula of freezing point, that is delta TF is equals to again the same thing, that is molality multiplied by Kf, right? Molality, this is molality. What is Kf? That is called cryoscopic constant or molar depression constant. Depression constant, right? If you see this here, what is delta TF? Larger minus smaller. Now the larger value is TF naught. So it will be TF naught minus TF equals to molality is W2 by M2 multiplied by, this is W1, this is 1000, and this is multiplied by KF, and this will be your final formula that you will use in the depression, in the freezing point. That is clear to everybody or not? Right, students? Okay. Daud ma'am, please read my full comment, ma'am. Okay. Which last video on JE or NEET? First, you tell me. I know that your comment is actually, guys, I was like busy the last few days. That's why I was like, I have not seen your comments. But don't worry, I'll see that. But you just need to tell me that which NEET or JE and which video we are talking about. Right? Okay. Now, let's see the next part, that is the graph, right? So, in the graph, the same thing we will do. Now, in the case of boiling point, we have kept atmospheric pressure as constant, right? We have drawn it like this here, right? But in this case, frozen solvent vapor pressure is also variable. Can you tell me why? See, atmospheric pressure will not change with temperature, right? Almost it is constant only, right? As you increase, it's not like I am boiling something, then atmospheric pressure is changing. Everyone is boiling and heating and melting something, so atmospheric pressure will not change according to that. But the vapor pressure of that solid solvent, that can change according to the temperature of that solid solvent. So we know that as temperature increases, the vapor pressure increases, right? Now, that's why we have drawn the vapor pressure of the frozen solvent like this. Now, the vapor pressure of the liquid solvent will be above than that. That will be like this, okay? And the vapor pressure of the solution will be lower than the vapor pressure of the liquid solvent, because vapor pressure decreases as we add non-volatile solute into it, and this particular point will define TF and TF naught. So we can say that this point is nothing but TF, and this point is nothing but it is TF naught, right? This point is nothing but it is TF naught. Can you tell me why? Because here pure solvent is touching the frozen solvent, so that is TF naught and this is TF, and the difference is delta TF. That is your graphical, like this is how graph is done. Okay, Anbu, we are taking classes. I have class like on Thursday and Friday in DNA batch, right? Yes. Understood everybody? Yes, everyone? Okay. Next is very, very important thing. I told you about KF and KB, right? This KF is nothing but cryoscopic. This is elliptoscopic constant. And the formulas also are very important for both of them. Reason being is now they are asking you question because based on these formulas as well. This is R multiplied by M1 multiplied by TF square by 1000 into delta H of fusion. And here replace fusion by vaporization and replace TF by TB, and you will get your answer for both the formula of elliptoscopic and cryoscopic constant. Right now, here you have, depending upon water, ethanol, they have their own Kf and Kb values that you can see here. You need to remember for water is 0.52 is Kb value and 1.86 is the value of Kf here. Right? Okay, students, very good. So now next thing is applications of depression in freezing point. See, applications you will see so many times, applications even in your house you can do the experiment. I'll post a short on that. I'm going to, because in class it's quite difficult to do the experimentation. You lose your interest in the theory parts, right? So that's why I'll make a different short on that and I'll upload that within 2-3 days. Right there you will see how you can do the experiment at your home also. You take up a glass of water, you add ice cubes and a thread into it, right? The ice cubes will not be able to lift the thread will not be able to lift the ice cubes. But as soon as you add salt into it, right, it will be able to lift the ice cubes because there is depression in freezing point, right? Now, if you see this here, this is used in anti-freeze solutions, right? In car, we have water also in the radiators. So in that, for example, you are going up in like very, very -5, -10 degrees Celsius. At that temperature, that is below the freezing point, so water will freeze, right? So we don't want water to freeze. If water freeze, our car will stop, right? So for that, what we do, we add a anti-freezing agent, right? We use in the car. Anti-freeze are added to the freezing point of the car, is depressed and water is not freeze because we want to lower. So that, see, if we see normal is 0 degrees Celsius is the freezing point. When you add a non-volatile solute, you make it that means you add an anti-freeze solution here, right? That means you add a non-volatile solute into this. What will happen? Let's say it is going beyond -5 degrees Celsius. So between 0 to 5 degrees Celsius, it will not freeze now. Earlier, it would have been freezed at -1, but now it will not freeze until -5. If you want even lower temperature, -10, add a solution like that. Okay. So that is your anti-freeze solution. And in like in the areas where there is snow, right? What they do is they sprinkle salt on the snow so that it decreases the freezing point and the snow will not further freeze to become a ice, right? Proper ice it will not become because the freezing point we have decreased. That is by adding a non-volatile solute into it. That is your freezing, that is your salt, right? Okay. Hello, Amrit. Yes, Amrit, on daily basis I take the classes. Okay. Now, let us start with the next thing, that is the questions on depression in freezing point. First question is, the freezing point depression of Kf of the benzene is 5.12. They are saying freezing point is Kf is this much. Okay, Kf is given to you. The freezing point depression for the solution of molality this containing, molality is given to you. Freezing point depression, that means delta Tf they are asking you. Non-electrolyte solute in benzene is round off up to 2 decimals. Okay. Okay. Benzene, you have added some containing non-electrolyte solute in benzene is rounded up to. Okay, simple. Delta Tf is equals to molality, right? Non-electrolyte solute. That means, see, non-electrolyte. Electrolyte will associate, and that will give rise to want-Hoff factor. Right? Today we are not discussing want-Hoff factor. In the next class we will discuss that. Right? So it is the non-electrolytes. That's why want-Hoff factor we are not writing. Right? So you can just ignore that. This is Kf. Molality is 0.078. So many students who are very new to this particular chapter. Ma'am, what is want-Hoff factor? Bit of want-Hoff factor is called I, that is applied here, right? But for non-electrolytes, I is equals to 1. That's why we are not writing it here. Want-Hoff factor itself is a different topic, so that's why I'm not writing it here, right? So this is molality. Kf is given to be 5.12. You multiply, you will get the value of delta Tf. Round it up to 2 decimal digits, and you will get your answer here. That is giving out to be 0.40 is the correct answer here. right? Okay. Yes, everybody. Good. Great, great, great. Yes. Oh. Next is NEET 2027 question, that is, if molality of dilute solution is doubled. Now they're saying dilute solution molality is doubled, the value of molar depression constant Kf will be. Okay. See, Kf will change. Tell me one thing, Kf will change with molality or not? Kf will change with molality or not? Kf depends upon molality or it depends upon the nature of the solvent. It's water, it's benzene, it's ethanol. It depends upon that thing, right? So what will happen? It will remain unchanged here. So many students, what they do, delta Tf is equals to Kf into molality, ma'am. M and Kf are, ma'am, inversely proportional. No, right? That will not depend upon the molality. It only depends upon the nature. It is water, benzene, or what, right? Next question is, a solution of sucrose has been prepared by dissolving this much of sucrose in this much of water. Freezing point of solution obtained will be freezing point of solution. Okay. That means what you have to give me is the answer for freezing point of solution obtained will be delta Tf. If you can see the difference here, they are asking the value of delta Tf here. A solution of sucrose has been prepared by dissolving. See, Tf naught is nothing but 0 degrees Celsius for water. You're adding sucrose into it. We're dissolving this much of sucrose in this much. This is molality. Molality is W2 by M2 multiplied by W1 multiplied by 1000 multiplied by Kf. Kf is given to you. This 1000 gram is nothing but W1. This is W2. M2 of sucrose you can easily calculate from the formula, right? Kf is also given to you. So everything is given to you. You just need to put the value of Kf, W2, M2, W1 and you will get your answer here. Very simple. Put the value of W2, this and this. Sucrose formula is double of glucose. So you can see that is 342, not the double, yes. 342, right? This, ma'am, we have no idea about sucrose, glucose. Don't worry, we are going to study this in biomolecules. In biomolecules, we are going to study the formulas of sucrose, glucose, maltose, fructose, galactose, everything, right? So this formula you can calculate from there, right? And then put all the values here and you will get the value of delta Tf. That will be your correct answer. Now see this value here. Delta Tf you can calculate from here. They are asking you the freezing point of solution, that is Tf they are asking you. So delta Tf is equals to Tf naught minus Tf, right? Depression in freezing point, right? Tf value will be equals to Tf naught minus delta Tf. Here this is given in delta Tf we have calculated as 0.372. 0 minus 0.372, that is minus 0.372 will be your answer. So answer will be A is the correct answer here, right? Answer will be, we will try, very good. Ma'am, we will solve, ma'am, please give us so time, ma'am. Okay, we'll try, ma'am. I know you can easily answer, right? I know that. That's why I give you the homework so that you can answer on your own pace, right? If in the class I start giving the time and all, now what will happen? Some students will vanish off. They'll be like, ma'am, we are not able to solve, ma'am. Some students will be like, time is getting wasted, right? And it will take around 3 hours to complete this lecture then, right? So that's why I'm solving it along with you only, right? Let's see the next question, everybody. Very good, very good, very good. Let's see this here. Two solutions A and B are prepared by dissolving 1 gram of non-volatile solute X and Y respectively in 1 kilogram of water. The ratio of depression and freezing point of A and B is found with this ratio of molar mass is what? Simple thing, we know that delta TF, depression in freezing point, the ratio of depression in freezing point is this. Delta TF of A divided by delta TF of B. It is directly or inversely proportional. We know that delta TF is equals to W2 by M2 multiplied by W1 multiplied by 1000, right? And this is KF. That means delta TF is inversely proportional to molar mass, because they are asking the molar mass of X and Y. So delta TF, for A we have two ratio of depression freezing point of A, two solution. That means solute A belongs to solution A. This belongs to solution B. So here you have molar mass of A. So this you can write molar mass of X, right? This you can write molar mass of Y, right? Everything else is equal by dissolving 1 gram of this and this respectively in 1 kilogram of this. Everything is same here, right? W2 is same, W1 is same, KF is same. So we don't need to write all the values here, right? So what you can do, this delta TF of A by B is nothing but 1 by 4. So M of Y by M of X. They are asking you molar mass of the ratio of X and Y. X and Y they are asking you. So the ratio of X and Y is going to be 4:1. If you see this here, 4:1 is not given to you here. But if you see this thing here, that is, if you see this option here, that is 1 divided by 0.25 is nothing but that is 100 by 25, that is nothing but that is 4/1. So that means the answer is going to be B is the correct answer here, right? Okay. So the answer is 1 ratio 0.251. Very good future IITian. Very good. Okay. What's your name? You need to, Ria, is it? Okay. Last colligative properties, osmosis and osmotic pressure, that we are going to talk about now, right? 3 colligative properties we have discussed till now. Now we are going to discuss last colligative property, that is osmosis and osmotic pressure. Shall I start with that, everybody? Yes, everyone. Osmosis and osmotic pressure. See, if you have ever soaked almonds in water for overnight, what you will see? Almonds will get swell up, right? Raisins will get swell up. Why? Because of the process of osmosis, right? So let's understand osmosis. So for osmosis, it is the movement of particles across a semi-permeable membrane. You have a semi-permeable membrane and the movement of particles across it is called osmosis. First, you need to understand what is a semi-permeable membrane. That is a very small membrane which allows smaller particles, appears to be smooth but contains network of sub-microscopic pores which allows smaller particles pass through while larger molecules are restricted. That means only solvent particles can pass. Solute particles are larger, they cannot pass. Okay, only the solvent particles can pass through them, right? Okay. Sai, I think you need to watch first and second lecture of solution chapter, then you will not ask me this question, right? Okay. So solvent particles can pass through it, solute particles will not pass through it. That is the first thing. Now naturally in animal origin you have pig's bladder, you have vegetable origin parchment, in synthetic you have cellophane, that is your semi-permeable membranes, right? Okay, so you can see semi-permeable membrane in a like cell also, in the human cell also. The plasma membrane of cell is the semi-permeable, right? You guys are NEET aspirants, so you can easily understand this thing, that the plasma membrane in your cell that allows the particles to move through it, that is your semi-permeable membrane example, right? Now, if you see that, ma'am, now you have talked about semi-permeable membrane, but ma'am, solvent particles are moving. But which concentration? Higher to lower or lower to higher? Right? Understand this thing. So osmosis is the movement of solvent particles across a semi-permeable membrane from higher concentration to lower concentration. Right? Okay. Higher, that means they move from higher concentration of solvent to lower. If you talk about solvent concentration, they will move from higher to lower. Higher concentration of solvent to lower. If you talk about solution concentration, they will move from low to high. Solute is also low to high. I'll explain you why. See, if you think that solvent is in high concentration, if there is a, this is 1, this is B, 2 solutions, then here you have less water, you have more solvent. Here you have more solvent, that, but you have less solute, right? So these things will go opposite, right? So if you say that there is a solution which has high concentration of solvent, automatically high concentration of solvent means concentration of solute will be low. And when the concentration of solute is low, that solution is called low concentrated solution. In a solution, we talk about the concentration of solute. If the concentration of solute is low, that solution is called low concentrated solution. If the concentration of solution is high, we simply write high concentration of the solution. Okay, right? Okay, students. So that is why we say that solvent, it will always move from higher concentration of solvent to lower concentration of solvent. For solution, it will move from low concentration to high concentration of solution, low to high concentration of solute. This is of solute, this is of solution, this is of solvent. Okay? Yes, everyone. Now, osmosis is the movement of solvent particles across semi-permeable membrane from higher concentration of solute to lower concentration of the solute. Wait a minute, lower to higher, nahi. For solute, it's opposite, right? So from lower concentration to higher concentration of solvent, this should be for solvent. So I'll just erase this thing here, right? Yes. Now let us see this thing here. That is the experiment where you have semi-permeable membrane. So what you do here, what you did, you added water. You had a beaker where you added water into it, right? Now that is your solvent. Now what you did, you had some small semi-permeable tube here, right? This is a semi-permeable tube. In this you have the solution. In this you have the solution. Let's say you have solute plus solvent, you have water plus sugar. Let's say you have water plus sugar or anything you can add. Basically, you have solute plus solvent. Now, here you have solute, here you don't have solute. So tell me what will happen. Osmosis will happen from which concentration? Solvent particles will move. Solvent particles will move from its higher concentration to lower concentration. And if you see, here you have solute. Here you have, in the solution, you have solute. So concentration of solute will be higher. Solute concentration high. That means opposite is low. Solvent concentration will be low. Solution concentration will be low. Here what you will have, there is no solute. So solute concentration is low. Solvent is higher and solution is higher. So can I just write here that the particles will move, the water particles will move from solution to the, from the solvent to the solution, right? So water particles move from solvent to solution. Solvent to solution. Okay. Water particles will move from this area to this area. and that is called the osmosis. Okay, and that is called the osmosis, right? Now, similarly, if you talk about let's talk about the almonds. If you soak almonds overnight in water, what happens, right? So you have a bowl of almonds, right? So you, let's say these are your almonds, right? So this is water, right? So now we know that inside the almond there is water concentration is less. Less concentration of solvent is there inside almond. Outside you have more concentration of solvent, that is water. So that's why water will move inside the almond. Can you tell me why? Because it always moves solvent particle from the higher concentration of solvent to lower concentration of solvent. So that's why the almonds will swell, right? Okay. Now let's see the formula here, right? What is osmotic pressure? For osmotic pressure, now you need to understand this diagram firstly. Okay. So let's see this experiment here. So in this experiment, you have this semi-permeable membrane. This is your solution and this is your solvent side. In solution side, you have two things. In solution side, you have solute. I'm writing it here. You have solute. You have solvent. Here you have only solvent. Here you have only solvent. Now understand one thing, students. If you have solute and solvent both here, can you do one thing here? Can you do one thing? This is solute, this is solvent. Solute, what you will write directly here. In this solute is more or solute is more here. Comparison, we can say there is no solute, there is more solute here. So solute is more in this case, here solute is less. No solute is present, so it is less, 0, right? Here, if solute is more, then solvent will be less. If solute is less, solvent will be more. Opposite they are, right? If solute is less, then solution will be less. Solution will be more concentrated. Here, solution is less concentration, right? That I told you, solution depends upon solute only, right? Now tell me where the water particles will move. Solvent particles is only allowed to move from semi-permeable membrane. Should it move from solvent to solution or solution to solvent? It will always move from higher concentration of solvent to lower concentration. Higher concentration of solvent is here, lower concentration is here, so it will move from this way. It will always move from lower concentration of solution to higher concentration. Lower concentration solution, higher concentration. It will always move from lower concentration of solute to higher concentration of solute, and that is why it is moving here. So all the three definitions are marking it right. So the movement is from solvent to solution here, and that is your osmosis, right? Now, someone is saying that, ma'am, please stop this osmosis, right? So what you will apply an external pressure here. That is mentioned by this pi, right? So this is called osmotic pressure. The external pressure, the minimum external pressure required to prevent the flow of solvent particles from lower concentration of solution to higher concentration of solution. I know students are more confused about, ma'am, higher concentration, lower concentration. Depends. You're talking about solution or solute or solvent, right? Okay. So that is your osmotic pressure, right? Now, osmotic pressure is directly proportional to your mole fraction, concentration. So it is directly proportional, directly equal to CRT, right? CRT this is nothing but concentration is expressed in terms of molarity here. Molarity. So this is nothing but this is number of moles divided by volume in liter. RT, this is your osmotic pressure, and this is the formula that you are going to use for the osmotic pressure. Okay, this is the formula that you are going to use for the osmotic pressure. right? Now, if you talk about osmotic pressure, let's talk about hypertonic, and these solutions. See, isotonic solution is when the osmotic pressure of two solutions are equal. That is called isotonic, right? Hypertonic is the one which has more. If you talk about osmotic pressure of 2 is greater than osmotic pressure of 1, then this 2 is your hypertonic, this 1 is hypotonic, right? The one which has more osmotic pressure is called hypertonic, the one which has less osmotic pressure, that is called hypotonic, right? Okay, yes everyone. Now let's talk about reverse osmosis here, right? This is fresh water, this is salty water. What is exactly happening in reverse osmosis? Let's talk about reverse osmosis. Okay. How many of you drink the water of RO in your houses? Right? How many of you take the water of RO, drink the water? Yes, beta, that will be there. Right, Gokul, that will be there at 6 p.m. The classes we will take from class 11. Baswa sir has taken class today for class 11. That is at 6 p.m. Okay. Now, if you talk about reverse osmosis, same system that is applied in our RO, right? So here, when we apply more pressure than the osmotic pressure, when the external pressure is more than the osmotic pressure, then reverse of osmosis will happen. That means in osmosis, solvent particle moving from its higher to low concentration. Now reverse means solvent particles will move from low to higher concentration of solvent, right? For solute or solution, solvent particles only are allowed to move, right? They will move from higher to lower concentration for solute and solution, right? But if you talk about solvent, it will move from lower to higher concentration. Okay. So if you talk about this fresh water, this is salty water, right? In fresh water, what you have is only solvent, only water. Here you have solute, you have salt plus water. So here I'll just write here you have only water. We know that solute is present here, that means here solute is more. You can write solute is more. Here solute is less. That's why here solvent is more. Here solvent is less. Now, in osmosis, what could have happened? In osmosis, solvent particles will move from the higher concentration. Here solvent is less. Okay. Here solvent is less. Solvent particles would have moved from higher concentration to its lower concentration. This is osmosis. This is osmosis. When you apply the external pressure to stop osmosis, no flow will be there. But when you apply pressure more than osmotic pressure, reverse osmosis means now the solvent particles will start moving from lower to higher concentration, means from this to this. That is reverse osmosis. In osmosis, from this to this, reverse osmosis from this to this. Can you see now water will move from salty water to fresh water. So in this tank, in the end, you will have only the fresh water and here you will be left with salt. And that is called desalination. Desalination. That is called as desalination. Clear everybody? Okay, that is called as desalination. Now let's do questions based on that. Right, we are almost towards 1, 2, 3, 4. I think some 4 questions we are left with. Then the topic will end. But I think before that, I also need to teach you one more thing here. Right, wait a minute. Let me see if it is there somewhere here or not. Chal, it is not there, so I'll just write it here. One is, two things can be there. See, whenever there is intravenous injections are applied to our body, right, are injected to our body, then there should be some concentration of that intravenous injection, right? Otherwise, our body will react very differently, right? So let's say this is your human cell. Let's say this is your human cell. This is the human cell, and this is the human cell. Okay. This is the injection that you are applying here, right? This is the injection that you are applying. Wait a minute. This is the injection that you are applying. Okay. Let's say if the injection and the blood cell is isotonic, the osmotic pressure is same, no swelling, no shrinking will happen, right? But let's say if this particular osmotic pressure of this one is more, right? That means they are not, you can say their osmotic pressure are not same. That means let's say concentration of this human cell is 0.9%, I think. 0.9% of NaCl it is. I think so. I'm not sure. I think it is 0.9 only. Right? We can assume it is 0.9. Okay. So this is 0.9. Right? That is not important for you. What is the percentage? What is important is what will happen if you have a different concentration. Let's say you are injecting the concentration which is lower than 0.9%, and here it is higher than 0.9%. Okay? If the injection concentration is lower, this is defining the solute. That means solute is less. Here solute is more, here solute is less. That means solvent will be more. Okay? In this case, things are opposite. It is higher. This is 0.9. This may be 10. This may be 11. Right? Sorry, 1, 2, 3, 4. So it is higher. That means solute is more. That means solvent is less. Now we know that in osmosis, what happens? Solute will move from its higher concentration to lower concentration. So in this case, what will happen? The water, right? The water that is in the blood cell, what will happen here? The water from outside, from this injection, will move inside. That means, can you say it will swell up? Because the water is moving inside, right? But in this case, things are getting totally opposite here. Here, solvent is higher here and solvent is lower here. So the water will move outside. So what will happen? The cell will shrink in this case. So they can directly ask you, here what happened if you have an injection which is hypertonic. Hypertonic means here this injection was hypertonic. That's why hypertonic means more osmotic pressure. Osmotic pressure is directly proportional to concentration. If osmotic pressure is more, concentration is more, and that's why cell will swell up. In this case, the injection is hypotonic. Hypotonic means the injection has low osmotic pressure as compared to human cell. That's why the concentration is lower. That's why solute, you can say, sorry, it is higher, na? Wait a minute. Here you have lower concentration, no? No, this is opposite. I have written the opposite. Okay? Because we are talking about here you have lower concentration. Wait a minute, let me just. Here you have lower concentration means osmotic pressure is also low. So this will be hypotonic solution, right? That is having low osmotic pressure as compared to human cell. That's why the cell will swell up. And here you have hypertonic solution, right? Hypertonic solution, right? Okay, students. So that is about your hypertonic and hypertonic in case of human cell, right? Now, let's talk about some questions, 3-4 questions we will talk about, right? Let's talk about NEET 2024 question, that is mass of glucose required to be dissolved to prepare 1 liter of its solution, which is isotonic with 15 gram per liter solution of urea is molar mass is this. See, let's see this. Mass of glucose required to be dissolved to prepare 1 liter. Volume is given to you, that is 1 liter of its solution, which is isotonic with this thing. 15 gram per mole. Can you see this is gram per liter. Mass divided by volume. Okay. Isotonic with this particular thing. This is the formula of strength. This is not concentration, this is strength of urea is given. Molar mass is given to be this. But if you see this, you need to find the molarity, right? They are asking the mass of glucose required here. Okay? To be dissolved in 1 liter of its solution, which is isotonic with this. First, you can find the osmotic pressure of this one. Osmotic pressure of 1 will be equal to osmotic pressure of 2. Right? In this case, the osmotic pressure is nothing but concentration multiplied by RT. This is also RT. This is C1, this is C2. R will cancel. So can you just directly write it here? Can you just directly write here? This is C1 is equals to C2. Right? Here the concentration, mass of glucose to be dissolved to prepare 1 liter. Number of moles we have no idea. W is going to calculate. W1 of glucose we are going to calculate. Right? Number of moles is mass of glucose that we know 180. Right? Multiplied by volume in liter. That also we know that is 1 liter. C2 is nothing but with 15 this of urea. Urea is this. See, we know that what is concentration is molarity, that is number of moles, right? So that will be number of moles divided by volume, right? We know that number of moles is nothing but W2 by M2 multiplied by volume in liter. Volume in liter is given to be and mass is given to be 15. So that means this strength is given to be 50. So this is given to be 50, right? So what you can put here, W1, is it given to you guys? Is it given to you? Is it given to you or not? Mass, they are asking you to calculate of glucose. Molar mass we know, volume we know, right? This is given to be 51. M2 we know of urea. Urea M2 you can easily calculate, right? Put all the values, you will get your answer here, right? So what you will do, same thing we have done here. Mass is 180 here, volume is 1 here, mass of urea is 60, this is 15. You put all the values, you will get your answer here, right? I can even solve it here, right? If you want me to do that, right? You can easily solve it like this. This is W1, which is equals to W. This is nothing but strength that is already given to you, that is 15. 15 by M2 is 60. This will be M1. M1 is 180 and this is volume in liter, that is this much. So it will be 0063, 15 into 3. So that will be your answer, that is 45 grams. Right? So answer will be 45 grams is the correct answer here. Right? That's how to solve. First you need to know the formula, then see what they are asking you to calculate. Okay. Next is the plot of osmotic pressure. This is NEET 2024 question. The plot of osmotic pressure versus concentration. Right? Osmotic pressure versus concentration. For a solution, give straight line with slope this. The temperature at which osmotic pressure measure is done. Okay. Straight line slope is given to you. See, simple. plot of osmotic pressure versus concentration gives a straight line with slope of this. See, you need to understand one thing, that the slope is given to you, right? So if you see this here, pi is equals to CRT. If you compare this with slope, this is osmotic pressure and concentration. So this is y is equals to mx plus c. That is your straight line. C is 0 here. X is C. That is concentration. Right? M is the slope and y is pi. Right? So if you see, if you compare this, slope, that is m, it is equals to RT here. Can you see that is equals to RT? If C is the concentration that is defining X, then this RT will be slope, that is that is your mass. Okay, sorry, this RT will be your slope. The temperature at which osmotic pressure is done. Simple thing is, slope is given to you, that is 25.73 liter bar per mole. R value you have to put it in liter bar per mole, right? Temperature you can easily get here. Now, R value also they have given you, that is 0.025. You can also take it as 1 by 12. You can put it here, right? You'll put it here and you will get your answer of temperature here, right? Very good, very good, very good. After getting the answer, you will get the answer here. 25 by this divided by the R value, you will get the answer here. Is that clear? Students, one more thing, they have asked you this in degrees Celsius, right? So understand one thing, this you will calculate in Kelvin because this is in per Kelvin. This you will calculate the temperature in Kelvin, right? Then you also need to convert this into degrees Celsius. Okay, when you convert this into degrees Celsius, you have to subtract 273.15 from that, right? Okay. Right, everybody? Okay, that was in Kelvin, right? Because R value you have put it in Kelvin. Okay. Next question is 200 milliliter of aqueous solution of protein contains this much gram. Volume is given to you of protein contains this much gram. It's this much. The osmotic pressure of the solution at 300 is found to be this. Molar mass of protein will be, see, simple is pi is equals to CRT, that is C is nothing but W2 by M2 multiplied by volume in liters, right? R and T. Now students, if you see this here, 200 milliliter, this is given to you. If you put this in milliliters, you will have to multiply this by 1000, right? So now this is in milliliter is given to you, volume is given to you. Of an aqueous solution contains this much, W2 is given to you. Osmotic pressure, temperature is given to you. Osmotic pressure is given to you. Molar mass is what you have to find. M2 is equals to W2 by pi multiplied by volume in milliliter into 1000 multiplied by R into T. R value you can take it as 1 by 12. That is nothing but in fraction, it makes the calculations easy, okay? W2 you can put the value 1.26 multiplied by 1000 multiplied by 1 by 12 multiplied by 300. Pi is given to be 2.57 multiplied by 10 raised to power minus 3. And if you see this here, volume is given to be 200. You solve this and you will get your answer for M2 in grams. Okay? Yes, everyone. Solve this and you will get your answer, right? And that's it, right? So that's it for today, students. Now, everybody, let us see. We have completed colligative properties, right? Colligative properties, like 4 colligative properties we had, and we have completed that in just one lecture. Relative lowering in vapor pressure, boiling point elevation, depression in freezing point, and osmotic pressure. Everything we have done along with the question practice. Right now, what I would advise you, this is your homework, guys. Take a screenshot of this here. Very good, guys. Very good, Ria. 613 mole. Very good. Awesome. So take the screenshot here, and I want you guys to answer it in the comment section. What is going to be the correct answer? That is the first question. And this is going to be the second question that you have, right? Third question, so I'll just write down the questions here. First question, everybody. Second question of your homework. You can just take the screenshot here, write it down in the comment section. Third question, right? And that's it. These three questions you have to do. Answer I'll tell you in the next class, right? And this is our Telegram channel that you can follow for all the updates regarding Vedantu NEET English. And students, one very, very important thing is that here you will see DNA NEET 2026 batch, right? That is live here. Students have joined in the batch, right? So now even students have joined after the NEET results also. Those students who were waiting, but unfortunately they did not get the desired result, they have also joined now only, right? Because they were waiting for the result. So we can't ignore those students as well. But after some time, even if you join the batch, right, you will have a lot of backlog. So I would not advise you to delay it more, right? I don't know what you're waiting for. You are still waiting for something. Till results, still it was like understandable what you were waiting for. But now it's like high time you should join a batch. You should, because in batch, dedicated lectures, live sessions, we are taking mock tests, we are taking tattva modules are given to you. These kind of short notes are provided to you, right? Everything is there in the batch, right? That is just at 3999. The doubt solving sessions, everything is there going in the batch, right? You have your classes there, right? And fixed classes are there, right? You can see that. And the classes are from the 10:30 till 3:30 p.m. You have your DNA batch classes. We all are there in the batch, right? We all are teaching. The students are totally loving the batch classes. There is no spamming, nothing is there. So you can also talk to me, in the batch. I can also unmute you and talk to you if you want to ask something. So that is the great things that we have seen in our batches. That's why students are very highly disciplined in the batch. So I would advise you, the link is in the description. You can go and click here. And students, those who are confused, ma'am, I don't know, this is my marks, I don't know whether should I take drop or not, then students, click here, take one-on-one personal mentorship. Click here, and that is your, like, if you want to take a drop or not, you're confused regarding that, fill out the form, because here one-on-one mentorship will be provided to you, right? Now, for those students who are like, ma'am, I was almost like getting a good rank, but I don't know if I'm still confused, right? Ma'am, I am like 90% sure that I'll take, but ma'am, I don't know. I want to actually go in an offline center that actually provide me guaranteed rank improvement or 100% fees refund. For that, you will see at Hyderabad and Chennai, click on here, right? You will see 100% offline classes, right, for JEE NEET 2026 aspirants. This is only applicable for droppers and repeaters, right? And it's not like everyone will be enrolled to this batch. Students will be selected, right? Interviews will be taken, counseling will be done, how much passionate you are regarding your preparation. Are you willing to devote your 1 year dedicated to NEET or not? And based on that, students will be selected, and then after that, RIG batch, that is rank improvement guaranteed batch, you can get enrolled to, right? Okay, so guys, that's it. And yes, okay, so now I want all of you to write down in the comment section your answers, and that's it. Okay, okay, then bye bye, take care, see you all in the next class. Bye bye.